Hello all, welcome to this tutorial on data analysis. This begins a series of new recordings on data analysis using Python. In this session though, we'll start by talking about why we use Python for data analysis. We'll also look at the different packages that are available. A very brief overview. We're not going to get into the details, but overview of the different packages that are available in Python, and also talk about why these packages as opposed to traditional data structures in Python. Okay, and finally in this package we'll start with a package called numpy, and we'll be looking at the basics of numpy, and we'll also look at accessing and processing numpy arrays. This is a data structure we'll talk about later, and we'll also look at simple matrix operations. All right, and at the end of this Jupyter notebook there is some optional content that's available for you: special arrays and scalar operations. I'm just leaving it out there for you to look at. I won't be testing this for the exam. Okay, so you don't need to know the last part here, optional content. Okay, so let's get started. First of all, why do we need packages like numpy and pandas in Python? Why do we need them to perform data analysis? If you recall, Python is a general purpose language that's very flexible. It can be used for different things, including graphical computing if you want, right? We can use Python for backend and web processing. We can use Python for different things. Okay, for data analysis, there have been packages like numpy, scipy, and pandas that have been developed that allows us to perform data analysis very effectively. In fact, I would argue that over the last 3-4 years, these packages have made available so many libraries for performing data analysis that now Python is a serious competitor to special purpose statistical software like R or SAS. Okay, so again, obviously I told you in the beginning of the class, we do not need to know stats to be able to take this class. So I would assume we are going to do only very basic things here. So a knowledge of stats is not useful, but whatever concepts you learned here would be very useful in the future as you learn more about statistics, right? Because you would be needing these packages to perform this analysis. Okay. Finally, before we get into the specifics of the first package, numpy, I want to ask you, I want to ask you to pause and think about, why do we need these special packages? Why not use existing data structures like lists in Python to perform some of these operations, right? To perform some of these statistical operations in Python. The answer, as you might guess, is very simple. Lists, data structures like lists and dictionaries are very general purpose data structures that are good at doing a variety of things. But if you want Python to perform statistical computing, a lot of the statistical computing actually involves using matrices behind the scenes, then lists might be very slow and very inefficient. Okay, and also if you remember, lists actually has the ability to take multiple data types, right? That can also slow lists down significantly. So what other developers have done is, using these basic data structures, they've developed more specific data structures such as ND arrays in NumPy and something called data frames in pandas that allows us to do specific operations, things that we need to do using statistics. Okay, and we're going to be seeing ND arrays today in NumPy, and at a later time when we talk about pandas, another very important package, we would talk about data frames. Again, very important for you to know. Okay, so today, before we talk about what we are going to do today, let me just review what I talked about before. The relevant packages for Python, to do data analysis. NumPy, we'll cover it. SciPy is based off NumPy. It's used for machine learning, like if you want to do very advanced, or even simple regression, neural networks, decision trees, and so on and so forth. You might want to consider looking at SciPy. And since I'm assuming zero statistical background, and since I'm not going to be teaching you stats in this class, we will not be using SciPy for our purposes. Okay, but if you would like to do, would like to perform machine learning, right? Would like to, let's say, use linear regression to understand relationships between different variables, I would advise you to go in and take a look at SciPy package. Okay, And we'd also be looking at pandas, which is another general purpose package, not general purpose, statistical package. Okay, that's also very useful, and we'll be looking at pandas a lot for this module. Okay, matplotlib and cborn are visualization packages. Again, we won't be getting into them extensively, but I will try to use whenever possible, simple visualizations using these packages. All right. And in this class, primarily we'll be using pandas, numpy, and matplotlib. Okay, so with that background, let's get in the weeds and look at some specific details on these packages. We'll start by looking at numpy. Again, to remind you, in this module, we'll be looking at numpy basics, accessing and processing numpy arrays, and simple matrix operations. Okay, again, all of this should be very simple for you to understand. It does not assume that you have statistical background. You will see what I mean, when I say it's very simple stuff that we're going to be talking about today. Okay, so let's get started. So let's look at NumPy basics. Okay, the first thing you notice, if you want to use NumPy to perform these operations, obviously you need to import this package. So I say import NumPy, and traditionally for me, import NumPy alone is sufficient. I don't need this as NP. But sometimes when you have packages that are very long, I would argue NumPy is not long. But if you want to use a shorthand, instead of typing in NumPy every time, you may want to give it a shorthand name. So I'm going to say import this package as NP, which simply means that whenever I want to invoke this package, instead of saying NumPy, I would be saying NP or whatever name that I choose to use here. Something short, hopefully. Okay, so if I don't use this, if I don't have this phrase here, then I would actually have NumPy. I would type in the full package name. Okay, so let's get started. The second line rather here, it should be familiar to you. I'm basically declaring, I'm not declaring, sorry, I'm assigning a list that includes 3 elements, 1, 2, 3, right? And again, notice that these are all numerical type, specifically integer, right? I'm assigning this list to a variable called lis, L-I-S, okay? Now, here's our first line of code that invokes the package NumPy. I'm, again, assigning a specific data type that I'm going to talk about in a minute, right, to this variable ARR. Again, as I mentioned several times before, these names, I use them to basically, use them to remind me of something useful, right? If you choose, you can have it X, Y, Z, A, B, C, anything you want, okay? So I choose to call this ARR, and I'm basically saying to Python that take this list that we just assigned to this variable list, right? Take this list, LIS, and convert this to an array. Okay, then I'm going to talk about what this means in a few minutes, but just note for the time being that I'm converting this to a different data structure. Okay, so it's numpy.array or np.array in this case of a list. Okay, so let's see how this looks like. So if I try to print list and array, what do you think is going to happen? Okay, so I just printed this, and you notice that list looks exactly like what you might expect. An array, for most purposes, also looks kind of similar, but slightly different. Okay, and if you actually typed in, I'm just going to come here. Let me change this. If I typed in and asked Python what type is list or this variable LIS, again, you probably know this answer by now. It's going to tell me it's a list data type. Okay, what do you think the answer would be if I type in ARR? Obviously, it should not be list. It should be something that's different, that's more special purpose data type. Okay, so let me run this. It's going to tell you that it's an array called numpy.array. Okay, so it's a special purpose array that's been created, right? That we created using the package NumPy. All right. So we're going to see in the next few minutes that creating this special purpose array actually makes it very easy for us to be able to perform certain operations. Okay, much easier and much more efficient than if we were to use list data type from Python. Okay, so let's move on. If I wanted to print array, rather the variable ARR, right, I could simply use the print command, but sometimes I can use the interactive feature of Python just run this cell, right? Let's see what happens. So it's going to tell me again, affirm that it's a special array. Same thing as ND array, right? It's going to tell me it's not a list, it's an array type. Okay, so I can print using a print command, or I can also interactively ask Python, okay, hey, what is array? Okay, or what is ARR? And if I wanted to access individual elements of the array, right? Again, I can use a print command, or I could use the interactive feature. I find it easier, instead of typing everything print and all that, I find it easier just to ask Python, hey, what is this? Okay, so in this case, ARR in this in parenthesis 1. Think about what you would get as a response if we had list here, LIS. Think about what you would get as a response if I had asked Python this, right? Now think about what might happen with ARR1. I would guess that it should be pretty similar. It's going to go here. It's going to say, here's the index 0, here's the index 1, here's the index 2. So maybe ARR1 should be 2. Okay. So the answer will be very similar to a list. Okay. Again, there will be differences, and also the operations behind the scenes. If you actually do benchmarking test, you will actually find that operations, even if it does similar things, operations using an ND array would be much, much faster. And that speed is important when you're running statistical analysis, especially statistical analysis of data sets, with thousands or even millions of rows. Okay. So now let's take another list, right? 4, 5, 6 with items 4, 5, 6. Assign it to a different variable called list1, right? I can of course choose to assign it to an array1, ARR1, but let's not do that for the time being. I want to do something more advanced. So we know that we already have a variable called lis with this value. Now we are creating a second variable called lis1 with this value, right? Now I want to make a slight modification to this, right? np.array. What else can we put in there? So what I'm going to do here is, if you notice, open parenthesis, close parenthesis, and now I'm basically inputting two values. It's a list. If you notice, lis is a list, lis1 is a list, and I'm actually using square brackets to indicate that I'm passing a list of lists, right? So two lists here, okay? And I want to print this variable mx, okay? And if you want to know what the shape of this matrix is, all you need to do is type in this function here, mx.shape 2, 3. And again, it's mx because the variable is mx. If I had this as a, then it would be obviously a.shape. The variable name dot shape would give you the shape of the matrix, or in this case, the shape of the two-dimensional matrix. Two-dimensional arrays. Okay, and again, remember it's a type of a numpy array, ND array. Now, if you want, we can always do this. Try to find the type of mx. Okay, so you see that it's a numpy ND array. Okay, now let's see what the data type is of this. Again, type is the data structure. By typing in dtype, mx.dtype, I'm actually looking for what type of elements are inside this array. Okay, and it's going to tell you it's an integer type. Okay, and again, the type of elements used for NumPy is slightly different, and I'm not really going to get into all the different possibilities for NumPy. Okay, just going to give you the highlights of important stuff that you need to know for NumPy. Okay, now if you want to access, let's say, if you want to access the first element or the second element of this matrix or the two-dimensional array, hopefully you remember this from the previous time. You would basically be accessing it just similar to the list. So you would say mx open bracket. I'm going to type this here so you can see this. I'm going to cover this one more time a bit later. Okay, so you can say this. This basically means it's going to be accessing the first row right here. First row, right? 1, 2, 3. Okay. And if I say mx0, 0, can you guess what this is going to be? Take a moment to think about it. So this element should be, right, first row, first column. That's 0, 0. That's the item number 1. Okay. So what I'm trying to do is, right now we have a value for that element, the 0, 0 position. The value is 1. By saying it should be equal to 10, I'm assigning that value. Now I'm making it to be 10. Okay, so let's see what it prints. Let me run this first. I just ran this. Okay, and I'm going to print this. Now you should see that the value there from 1, it has changed to 10. Okay, so this should be fairly obvious. Again, these operations kind of closely mirror what you would see in a list. Okay, now let's try this. So I take the same thing, right? Same element. Right now with a value of 10. I'm trying to assign a value of 15, but the difference is it's not really an integer. I actually put in quotes, so it's a string. Let's see what happens. I'm going to run this. Okay, I just ran this, and I'm going to run the matrix again. Okay, and you see that 10 has become 15, but it is not really a string. It converted this, as long as it's valid, to 15. Okay, so let's try what I try here. Right? Let's try what I have here. Type in something, right? That's not necessarily not necessarily can be converted to an integer type. Okay, let's run this, assign this, and you see that you cannot do that. Okay, so the one good point, the important point that I want to make here is that by default these arrays work with one data type. Mind you, I'm not saying they have to be integers, but they work with one data type. They tend to be numeric. They can be integer type. They can be type float with a dot next to it. Okay, so if you try assigning some other data type, then you're going to have an error message. Okay, at least in this case. By the way, again, I want to mention we are not looking at the more advanced types of arrays in NumPy. It is technically possible for me to make the first row here to be string type, but it's very complicated. Not very complicated. It's a bit tricky. It's more complex than necessary. Those kind of things are better done by moving to a different package like pandas. We're going to talk about data frame from pandas. For the time being, the main point I'm trying to make here is that the reason why some of the operations here are so fast and better than the list is that we give up some of the flexibility. We basically say that we are going to try to use, right, elements of the same type. Okay, maybe numeric type, could be integers, could be float. Okay, so that's the point I wanted to make. So let me change this back. Let's say I'm going to put 15, or maybe let's say 20, right? Let me run this and try printing. Again, I should change to 20. Okay, so that brings to an end some of the basic operations for the NumPy matrix. We looked at the one-dimensional and the two-dimensional array. Okay, and I also wanted to show you a couple of other neat ways of generating arrays. Okay, for example, let's say that I don't have an array right now. I want to start and create an array from scratch. I could use this function called arange. So np, and again, just to recall, I'm using np because I imported NumPy as np, right? Let me go back here. So I imported NumPy as np. If I do not do this, then I would be calling this NumPy, right, dot arange. Okay, so if I say this, and now we go back to kind of similar structure, similar sequencing operations we looked at for the for loop. If you remember that, we used range and 10. Similar thing is going to happen. The only difference is it's an array. So if I type this and run this, you're going to see an array. It's a NumPy nd array, right? With elements starting from 0 all the way to 9. There will be 10 elements in this array. Okay. You can also do slightly more advanced operations. Again, you should be able to guess what should be the output. If I had 20, 100, and 5, it's simply going to start at 20, increments of 5 until it hits 100, but does not include 100. Okay, so the one before 100 is 95. So this is a nice way of generating arrays fast. Okay, so these are the basics of NumPy. Now what I would like to focus on the next few minutes is trying to look at ways of accessing as well as processing these arrays. Okay, Again, I want to remind you that this section is also is required, so you need to be looking at it also for the exam. Okay, so now let's start from scratch. Let's say that I create this new array, new array, and I assign it to this variable ARR. Okay, and this is what I did: 10, 55 to 5. Take a moment. It looks in structure, in terms of structure, it looks very similar to the previous command we used for npy.arange. Think about what would this array look like. So I'm going to run this, and unsurprisingly, this is what you have: 10 all the way to 55, but not including 55 in increments of 5. Okay, so we have an ND array from numpy package, right? And again, in terms of accessing elements of array, right? If I had ARR, that's a variable name, right? And in square brackets, if I had 1, think about what element would be printed: 0 and 1. So it should be 15. Let me see. I'm going to run this. So you see the value of 15 being printed. Okay. And slicing should also be very similar. Okay. So if you look at the slicing operation here, I say, again, think back to elements, strings and lists. If I don't have anything in the beginning, it basically means start from the beginning, from the 0th position, go all the way to the 5th position, but do not include the 5th position, right? So starting at 0, 0, 1, 2, 3, 4. 5 is here, but don't include it, so it should stop at 30. Okay. Let's print this. So it creates an array, I mean, we haven't assigned this to any other variable, so this is somewhere out there, but we basically have a subsection of that: 10, 15, 20, 25, and 30. Okay. Now another neat function using numpy, what we can do is this slicing we just did, for example, right? Start from the beginning all the way to 5, but don't include 5. I can assign them all a value at the same time. For example, this would basically take these values and make them whatever I assign this to be. In this case, I make it 51. Let's say 21, 51. Whatever I put in there, that's going to be the value now that's going to be assigned to these elements. Okay. And again, remember this. Think about this. We have the original array, ARR, right? Right now it has 1, 2, 3, 4, 5, 6, 7, 8, 9 elements, right? And I'm basically saying take the first 5 elements of the 9 and make it 51. And if I want, after running this, what should be the value of ARR? Let's see. So again, unsurprisingly, the first 5 elements are going to be 51, and then the array continues. The last 4 elements are similar to what we had before. Okay. And next, what I would like to focus on is some subtle points about these operations. And by the way, this operation is called broadcasting, assigning a value to this index range, right? So now I want to get us started about some subtle points regarding slicing as well as copying. Okay. So let's start from scratch again. Okay. So let's create an array, a variable called ARR. Okay, and assign this value. So it should be very similar to what we saw before. Let me run this code and see what comes up. It should be very similar to what we had before. So array has the value, the variable ARR has the value, of what you see here. Now let's create another variable called ARR underscore slice, a slice of that array, right? And assign this to the value, which is a subsection, a slice of the original values. Okay. Now let's run this. And I should see that it should be the first 5 elements of the original variable ARR. Okay. Now let's see something. Let's look at something. The broadcasting operation we looked at last time. So take these elements, right? And in this case, I'm actually changing all of the elements. I can have it 3 if you want. It doesn't matter. I'm just going to leave it as is. I'm changing the elements up to the 5th position, but not including 5. That should be all of them. Okay. 0, 1, 2, 3, 4. And assign that a value of 12. Okay, and let's see what the value of array slice is. And you can see again, it's not surprising. The value of the values inside this list or array, should have changed to 12, 12, 12, 12. Okay. Now my question is, what do you think would happen to this original element we had, which is called ARR, right? That had this first 5 elements that we sliced, assigned it to array slice, right? But that variable is still hanging around. Okay. And it has additional elements 35, 40, 45, 50. Do you think that variable would be affected by this operation. Look at this. Again, I want to ask you this question because we did the broadcasting operation on the other variable, array underscore slice, or ARR underscore slice. Okay, so let's look at what's happened to ARR. Interesting. So you can see that whatever operations we performed on that other variable, ARR underscore slice, they've impacted the original array as well. The first 5 elements are also 12, 12, 12, 12, and then the other 4 elements are unaffected. So the main point that I want to make here is that the behavior here is not the same as for lists that we looked at before. Okay, and again, we spent a lot of time talking about aliasing. I just want to write this here so you can see behavior of lists. We spent a lot of time talking about aliasing, right? And here the behavior is different. Okay, so if you want to be safe, what you need to do is explicitly use a copy operation. Okay, so what you need to do is, let's say that I create a new array from scratch, ARR np.a range 10 to 55 with increments of 5, not including 55. So I want to create a new element, new variable, and explicitly use the copy method. Okay, this way whenever we try to work on ARR1, it's not going to have an impact, will not have an impact on ARR. Okay, so just wanted you to think about this a little bit. Okay, and I want to emphasize that some of the concepts we discussed when we discussed aliasing, it's going to be different for numpy ND arrays. Okay, again, the logic behind this is actually quite simple. The reason why we don't use the same aliasing techniques or same aliasing concepts is that here it's explicitly designed to impact the original array. Because what the creators of numpy package did not want to happen is that when you have a 2-dimensional array or a 3-dimensional array of, let's say, thousands of rows, you don't want to willy-nilly copy those elements, onto a different variable and have them running around, have them hanging around in the main memory, the RAM memory. That can significantly slow down performance. Okay, so for data analysis operations, the way numpy package is written, most of the time we'll be working with the original array. Okay, the operations we perform will impact the original array. This minimizes use of memory, makes it more efficient, makes it fast, and so on. Okay, and the counterpoint to this is that if you do want to be careful so that you don't make unintended changes to the original bunch of elements in an array. Okay, so these are the main concepts I wanted to talk to you about when we discussed the accessing and processing of numpy arrays. Okay, now there's a third subsection that I want to spend a few minutes on. That would be simple operations, simple matrix-like operations. Okay, again, shouldn't take long, but I just wanted to spend a few minutes, 3 to 5 minutes talking about this. Okay, so now let's again think about this. Here are 3 list variables, lis1, lis2, lis3, as they have been assigned specific values. Again, they are lists, obviously. Okay, now what I'm doing is assign these lists, right, to a different to another variable called mx. Okay, and I'm using the array method. Again, you should be familiar with the array method. This is how we created ND arrays from scratch, right? Numpy arrays from scratch. So one thing that I want to point out, maybe I didn't do this before, notice the use of 2 parentheses and 2 parentheses. Okay, that's very important for this to work. So this is going to be a list of lists. List 1, list 2, list 3. And now let's try to run this. Okay. And the code is ran. Now let's see what happens here in terms of the matrix. What value do we have? So now we have an array, right? That's 3 by 3. Okay, again, if you want to know the shape, if you didn't know it, you can always type in mx.shape. Should get 3 by 3 as the response. Okay. And finally, how do we access elements within this array? And let me move this up a little bit so you can see this. So I can type in mx2. What do you think will be the output? Think about this. I only have one index here. This is a 2-dimensional array. So by default, it's going to be looking up rows 0, 1, and 2. So it's going to print this row, which is actually the third row, but because we start from 0, this is in position 2. Okay, so it should print the list 40, 45, and 50. Or rather, I'm sorry, I meant to say the ND array. Okay, 40, 45, and 50. Now, if I want to access individual elements, right, I need to use both dimensions. So let's see what this will do. mx1, it's going to look at 0 and 1, this row in the middle right here, right, and 0 here, right. This is the second index, right. That's going to look at the 0th column, which is the first column here. Okay, so 1, 0 in this case would be the second row, the first column, that should be 25. Okay, so let's run this. So you see 25. And if you want to assign this to a value, let's say 35, that will change the value of the array. Okay, now I can also slice these two-dimensional arrays. Okay, so for example, here we have, again, notice a slightly different use of syntax. I have a comma here. Okay, so I can do, this is 2, which means position 2. So that's 0, 1, 2, third row, right? So third row, and I'm basically saying start from the beginning, right? And go up to the second, position number 2, but don't include number 2. So this position 0, position 1, position 2. So don't include the position 2. There should be 2 elements, 40 and 45 from the third row. Okay, let's see if this works. So that's an array, 40 and 45, ND array. It's going to return an ND array. Okay. Now, what do you think this does? mx1 colon, comma 1 colon. Okay. Think about it. Look at the array up top here. Think about what the output is going to be. Okay. So what this basically means for the first value, right? This is going to be the row. It's basically saying start from 1, right? That means ignore the 0 element and then go forward. And for the column, it's also basically saying start from 1 and then go forward. So ignore the 0th row, ignore the 0th column. That should be the bottom right-hand side corner of the matrix right here. 30, 35, 45, and 50. Okay, let's run this and see. So there you have an array, 30, 35. It's a two-dimensional array, 2 rows. Okay, 30, 35, and 45, and 50. Okay, so hopefully these concepts are clear. Okay, so we looked at basic concepts on NumPy arrays, and so this is the basics you need to know for our exam. Okay, and again, this is useful to know because we might be using some of these concepts even when we move on and look at pandas, which is a different package that I'm going to be talking about next. Okay, and with that, I also want to say that the content after this, I want to talk about a few more useful things, maybe another 5 minutes. I'm going to say it's optional. That means, again, you don't need to know this for the for your project. You don't need to know this for the exam. Okay, but let me go ahead and show you some interesting things, especially if you're interested in higher level mathematics. Okay, so if you want to create, this is a special function called zeros. These are special arrays that are useful in math and stats. So let's create a zero matrix with shape 3, 3. Okay. Again, notice the use of double parenthesis here. Okay, and close with double parenthesis. Okay, so it's going to create a matrix, two-dimensional matrix of shape 3 by 3. And it's going to assign all the elements the value 0, like this. And again, notice that by default, this one is using the float type. So far, we've been working with integer type up there, right? Now, when we use this, it's going to be creating a matrix with float. This basically means 0 dot. This really is 0, but just indicates, the dot indicates that it's a float type, decimal. Okay, so I can specify for the matrix, for the elements of the matrix, decimal values, which is useful, for matrix operations. And also, of course, for real life data. Okay, and what do you think this one might do? np.once. To make things simpler, let me make it 2. What do you think the output of this would be? It's going to create an array, right, of shape 2. So it's going to be a one-dimensional array. Okay, and we're basically saying assign the value 1 to all elements of this array. Let me run this. So we're basically going to see an array, 2 elements, but one-dimensional array. Okay, if I want a 2-dimensional array, So all I need to do is specify the shape 2, 2, and notice the use of double parenthesis here, right? And let's run this. So you're going to have a matrix with values 1 assigned to all of the elements, right? It's a two-dimensional matrix. And EYE here is an interesting way of calling the identity matrix. Again, I don't expect you to know what an ID matrix is or identity matrix is. So all I want to say is it's very, very useful for mathematical operations. Okay. For this, let me run this and explain this. It's easier. Let me run this. It basically means it's going to be a square matrix, right? Square meaning the rows and columns are going to be the same. The value is 3 rows, 3 columns. And we are basically saying assign all the diagonal elements here the value of 1. That's the identity matrix. Okay. So some useful matrices, ways of generating matrices using NumPy. All right. Useful for mathematics and statistics. Finally, I want to close with talking about simple scalar operations on arrays. Again, optional. Don't need to know this for the exam. Okay. So let's just look at what kind of mathematical operations can I perform on these arrays. Okay. So let's import NumPy as NP. Create a new array from scratch. ARR equal to np.array of this list. Okay. And ARR1 equal to np.array of this list 4, 5, and 6. Right. Now let's print the values of ARR and ARR1. So you're going to see 2 ND arrays 1, 2, 3, 4, 5, 6. They have the same shape. That's important. Okay. Now what happens if we multiply ARR with ARR1? It's simply going to multiply the individual elements. Let's see the value and then we can discuss this. So you have an array, right? It has the same shape as before. 3 elements, 1 dimensional. You got the results here 4, 10, and 18 because 1 multiplied by 4 is 4. 2 multiplied by 5 is 10. 3 multiplied by 6 is 18. Okay. So that's multiplication. So the other 3 operations here, addition, subtraction, and division should be pretty similar. If I add them up, right, it's basically going to, the first elements of the array are going to add up, second elements are going to add up, right? 1 plus 4 is 5, 2 plus 5 is 7, 3 plus 6 is 9, and that's what you see here. The same things apply for the subtraction. So I'm going to type this in. I'm not going to explain it. I leave it for you to check it. Okay, it's basically the element of 1, the element of the first array subtracted with the element of the second array. Okay, corresponding elements. And ARR1 divided by ARR2, again the same thing. Divide the first element of the first array by the second element of the second array. Okay, so this should give you some basic ideas of the operations, mathematical operations that are possible using NumPy arrays. Again, useful to know, but I'm not going to test this for you, in the exam. And so for the exam, really what you need is the content until this point, the slicing of matrix two-dimensional arrays. Okay, and finally I want to close by saying that I do have another Jupyter notebook on NumPy arrays. I'm going to upload it, and if I have time maybe at a later date, 1 week later, I will try to record a video for the part 2. Right now we have the part 1 here. I'll try to record part 2 for NumPy, but it's going to be completely optional, only for those who are interested. Okay, again, I don't want to promise. If I have time towards the very end, I'll try to record a video on this, the part 2. Okay, but I certainly will post the Jupyter notebooks for NumPy-02 on the course website, so you can take a look at it. But the content of that part 2 NumPy package is going to be completely optional. Okay, so next what we are going to do is we're going to look at pandas. Very important package, very interesting package. So we'll start working on pandas next. Okay, so see you soon.